Trigonometric identities. What is an identity and trigonometric identities? An identity is an equation that is true for all valid replacement of the variable. This is when we equate the left side of the equation that should be equal to the right side of the equation. Examples: x squared plus y squared equals 1. Whatever value we put in x and y, it should be equal to the right side. Another example is x plus 3x equals 4x. Whatever value we put in x and y, it should be equal to the right side. Next, what is conditional equation and trigonometric identities? Conditional equation is a statement that is true on condition that the variable is replaced with the correct value. Examples: x plus 5 equals 11. True if x is equal to 6. This is not an identity equation because when we say identity equation, it is any value of x that will be added by 5 should be 11. So, this equation is a conditional equation because we can substitute any value of x, and this equation will only be true if x is equal to 6. 3x equals to 15. True if x is equal to 5. If we substitute x by 5, 3 times 5 is equal to 15.
Trigonometric identity is an identity that involves trigonometric functions of one or more variables. The equation in reciprocal, quotient, and Pythagorean identities, which follow each truth, is true for all values of theta for which both sides are defined. So if we can still remember in our circular function, the point x and y, the y is the sign, and x is the coordinate, is the cosine. Sin theta equals y, cosine theta equals x, tangent theta equals y over x, cosecant theta equals 1 over sin theta or r over y, secant theta equals 1 over cosine theta or r over x, but x is not equals to 0. Cotangent theta equals 1 over tangent theta or x over y, but y is not equals to 0. Where y is the opposite side of theta, and x is the adjacent side of theta, and r is the hypotenuse. So from here, you can form different kinds of identities.
Reciprocal identities are the reciprocal of the 6 main trigonometric functions, which is sine, cosine, tangent, cotangent, secant, and cosecant. Every fundamental trigonometric function is a reciprocal of another trigonometric function. For example, cosecant is a reciprocal identity of sine function. 1 over sine theta equals a cosecant theta. The reciprocal of cosecant theta is 1 over sine theta. 1 over cosecant theta equals sine theta. The reciprocal of sine theta is 1 over cosecant theta. If we simplify or multiply cosecant theta times sine theta, that is equal to 1. So sine theta cosecant theta equals 1. 1 over cosine theta equals secant theta. The reciprocal of secant theta is 1 cosine theta. 1 over sine secant theta equals cosine theta. The reciprocal of cosine theta is 1 over secant theta. If we simplify or multiply secant theta times cosine theta, that is equal to 1. Cosine theta times secant theta equals 1. 1 over tangent theta equals cotangent theta. The reciprocal of cotangent theta is 1 over tangent theta. 1 over cotangent theta equals tangent theta. The reciprocal of tangent theta is 1 over cotangent theta. If we simplify or multiply cotangent theta times tangent theta, that is equal to 1. So tangent theta, cotangent theta equals 1. So from here, we can also form a different identity, and this identity is called the reciprocal identities. Quotient identities. Tangent theta equals sine theta over cosine theta. Remember earlier, tangent theta equals y over x, so sine theta is y and cosine theta is x. And that's why the quotient of tangent theta is sine theta over cosine theta. Cotangent theta equals cosine theta over sine theta. Remember earlier, cotangent theta equals x over y, so cosine theta is x and sine theta is y, and that's why the quotient of cotangent theta is cosine theta over sine theta.
We already know about Pythagorean is a squared plus b squared plus c squared. We have here x squared plus y squared equals 1. So, x squared plus y squared equals 1. The x is the cosine and y is sine. Substitute that. Square root of cosine theta plus square root of sine theta equals 1, or square root of sine theta plus square root of cosine theta equals 1. From this Pythagorean identity, we can form other Pythagorean identities. The three main Pythagorean identities. Square root of sine theta plus square root of cosine theta equals 1. Square root of tangent theta plus 1 equals square root of secant theta. 1 plus square root of cotangent theta plus square root of cosecant theta. By these identities, we can form other identities. The first main Pythagorean identities. Square root of sine theta plus square root of cosine theta equals 1. Let's say we will divide this whole equation by square root of cosine theta, so we can form a different identity. Square root of sine theta plus square root of cosine theta equals 1 divided by square root of cosine theta. Square root of sine theta divided by square root of cosine theta is equals to square root of tangent theta. In our quotient identities, square root of cosine theta divided by square root of cosine theta is equal to 1.
The second main Pythagorean identities. Square root of tangent theta plus 1 equals square root of secant theta. From this identity, we can still form a different identity. Let's say if we transfer square root of tangent theta in the right side, the equation will be 1 is equal to square root of secant theta minus square root of tangent theta, or what if 1 is transferred in the right side of the equation will be square root of tangent theta is equal to square root of secant theta minus 1. Or what if the equation square root of sine theta plus square root of cosine theta is equal to 1 will be divided by square root of sine theta. Square root of sine theta divided by square root of sine theta is equal to 1. Square root of cosine theta divided by square root of sine theta is equal to square root of cotangent theta. In our quotient identities, 1 divided by square root of sine theta is equal to square root of cosine theta. The answer will be 1 plus cotangent theta is equal to square root of cosecant theta. The third main Pythagorean identities. 1 plus square root of cotangent theta is equal to square root of cosecant theta. From this identity, we can still form a different identity. Let's say if we transfer 1 in the right side, the equation will be square root of cotangent theta is equal to square root of cosecant theta minus 1. Or what if square root of cotangent theta is transferred in the right side, the equation will be 1 is equal to square root of cosecant theta minus square root of cotangent theta. So, as you can see, we can manipulate the identities to find other identities by using our past knowledge in mathematics.
odd and even identities. Odd identity. Sine times negative theta equals negative sine theta. When you multiply sine times negative theta, the answer will be negative sine theta. When you multiply it and the answer is negative, that's an odd identity. Tangent times negative theta equals negative tangent theta. When you multiply tangent times negative theta, the answer will be negative tangent theta. When you multiply it and the answer is negative, that's an odd identity. Notice that the outside sign changed from positive to negative, that makes it an odd identity. Even identity. Cosine times negative theta equals cosine theta. When you multiply cosine times negative theta, the answer will be cosine theta. When you multiply it and the answer is positive, that's an even identity. Notice that the two sign is identical, that's an even identity. When we say odd identities, it is when you multiply the trigonometric function to negative theta and the answer will be negative. And when we say even identities, it is when you multiply
Sum and different identities. Cosine different identities, cosine A minus B is equal to cosine A cosine B plus sine A sine B. Now we sum. Cosine 15 degrees, we have to find the value of cosine 15 degrees using the cosine different identity formula, but how? So you need to ask yourself what two angles that are very common that has the difference of 15 degrees. Of course, two common angles on a unit circle would be 45 degrees and 30 degrees. Cosine 45 degrees minus 30 degrees substitute. Cosine 45 degrees minus 30 degrees is equal to cosine 45 degrees cosine 30 degrees plus sine 45 degrees sine 30 degrees. And substituting this, we need to memorize the unit circle with the corresponding coordinates. You can also make use of the two special right triangle if you can't memorize the unit circle. And recall with the circular functions, sine is y and cosine is x. Is equal to square root of 2 over 2 times square root of 3 over 2 plus square root of 2 over 2 times 1 half. Multiply square root of 2 over 2 and square root of 3 over 2 is equals to square root of 6 over 4 multiply square root of 2 over 2 and 1 half is equals to square root of 2 over 4. The equation will be square root of 6 over 4 plus square root of 2 over 4. Simplify. Square root of 6 plus square root of 2 over 4. Cosine sum identity. Cosine A plus B is equal to cosine A cosine B minus sine A sine B. Now we sum. Cosine 7 pi over 12. We need to convert this first from radian to degrees. 7 pi over 12 times 180 over pi is equal to 1260 over 12 is equal to 105 degrees. Well, cancel first the pi, multiply the numerators and copy 12 as the denominator, then divide. Now that we got the degrees, we will now find two common angles that adds up 105 degrees. Cosine 105 degrees, two common angles are 60 degrees and 45 degrees. Cosine 60 degrees plus 45 degrees substitute. Cosine 60 degrees plus 45 degrees is equal to cosine 60 degrees cosine 45 degrees minus sine 60 degrees sine 45 degrees. Based on the unit circle, their coordinates would be 1 over 2 times square root of 2 over 2 minus square root of 3 over 2 times square root of 2 over 2. Multiply 1 over 2 and square root of 2 over 2 is equals to square root of 2 over 4 multiply square root of 3 over 2 and square root of 2 over 2 is equals to square root of 6 over 4. The equation will be square root of 2 over 4 minus square root of 6 over 4. Final answer is square root of 2 minus square root of 6 over 4. Now that we're done with the cosine function, let's discuss about the cofunction identities. co-function identities, cosine pi over 2 minus b is equal to sine b. In answering using the formula of co-function identities, first, it depends on the given if it is a degrees or a radian. We should convert pi over 2 to degrees. Substitute b at the left side while the given on the right side b. Let's subtract cosine and sine will have the same corresponding coordinates whenever these two angles add up to 90 degrees. Sine pi over 2 minus b is equal to sine b. Same as the procedure on cosine and sine. Sine and cosine will have the same corresponding coordinates whenever these two angles add up to 90 degrees. Tangent pi over 2 minus b is equal to cotangent b. Same as the procedure on cosine and sine. Tangent and cotangent will have the same corresponding coordinates whenever these two angles add up to 90 degrees. Now that we're done with the cosine function and cofunction identities, let me discuss to you all about the sine function and tangent function.
Sine difference identity. Sine A minus B equals sine A cosine B minus cosine A sine B. Now the example. Sine 15 degrees. We need to find two common angles on the unit circle that has the difference of 15 degrees. Sine 45 degrees minus 30 degrees. Substitute sine 45 degrees minus 30 degrees is equal to sine 45 degrees cosine 30 degrees minus cosine 45 degrees and sine 30 degrees. Based on the unit circle, their coordinates would be square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. So, multiply square root of 2 over 2 and square root of 3 over 2 is equals to square root of 6 over 4 multiply square root of 2 over 2 and 1/2 is equals to square root of 2 over 4. The equation will be square root of 6 over 4 minus square root of 2 over 4. And the final answer is equals to square root of 6 minus square root of 2 over 4. Sine sum identity. Sine A plus B equals sine A cosine B plus cosine A sine B. Now the example. Sine 75 degrees. Two common angles that add 75 degrees is 30 degrees and 45 degrees. Sine 30 degrees plus 45 degrees. Substitute sine 30 degrees plus 45 degrees is equal to sine 30 degrees cosine 45 degrees plus cosine 30 degrees and sine 45 degrees. Based on the unit circle, their coordinates would be equals to 1/2 times square root of 2 over 2 plus square root of 3 over 2 times square root of 2 over 2. So multiply 1/2 and square root of 2 over 2 as fractions is equals to square root of 2 over 4 and multiply square root of 3 over 2 and square root of 2 over 2 is equals to square root of 6 over 4. So the equation will be square root of 2 over 4 plus square root of 6 over 4. Now we can combine this as a single fraction. Square root of 2 plus square root of 6 over 4. So that's the final answer to this equation. Now that we're done of sine functions, let's move on to tangent functions. Tangent sum identity. Tangent A plus B is equal to tangent A plus tangent B over 1 minus tangent A tangent B. Now the example. Tangent 23 pi over 12. Same as the cosine sum identity example. We need to convert this first from radian to degrees. So 23 pi over 12 times 180 degrees over pi. We'll cancel first the pi, then multiply the numerators and copy 12 as the denominator. Then divide. Now that we got the degrees, we will now find two common angles that adds up 345 degrees. Tangent 345 degrees Two angles that we can use are 120 degrees and 225 degrees. Tangent 120 degrees plus 225 degrees. A is going to be 120 degrees and B is going to be 225 degrees. So what's tangent 120 degrees? And recall with the circular functions, with a given, we can identify what's its reference angle depending on what quadrant does the given belong with each specific formula. 120 degrees is in quadrant 2 in a unit circle, so the formula would be 180 degrees minus theta. 180 degrees minus 120 degrees is equals to 60 degrees. Substitute theta with 120 degrees, then difference between 180 degrees and 120 degrees is 60 degrees. Using the 30 degrees, 60 degrees, and 90 degrees triangle, we could find out tangent 60 degrees, which will help us to calculate tangent 120 degrees. 30, 60, 90 triangle, if you remember from our SOHCAHTOA, tangent is equals to opposite over adjacent. So, opposite to tangent 60 degrees in the special right triangle is a square root of 3. Adjacent is 1. Tangent 60 is a square root of 3 over 1. It's a square root of 3. If you still remember from our circular functions, tangent is positive in quadrant 1 but negative in quadrant 2. So, tangent 120 degrees equals negative square root of 3. What about tangent 225 degrees? 225 degrees is in quadrant 3 in a unit circle. 225 degrees minus 180 degrees is equals to 45 degrees. Tangent 45 degrees in a 45 degrees and 45 degrees and 90 degrees triangle is 1 over 1. So it's positive 1 because in quadrant 3 only tangent and cotangent are positive. So tangent 225 degrees is equal to 1. Substitute the square root of 3 plus 1 over 1 minus negative square root of 3 times 1. So this is the same as 1 minus square root of 3 over 1 plus square root of 3. The numerator can be written as like that because on their positions. They still have their own specific signs. In the denominator, 1 times negative square root of 3 is still equals to square root of negative square root of 3. There are two negatives, so it became positive and the operation became addition. To simplify these complex fractions, what we need to do is to multiply both the top and the bottom by the conjugate, the denominator. The conjugate of the denominator is simply just change their sign. So 1 minus square root of 3 times 1 minus square root of 3 over 1 plus square root of 3 times 1 minus square root of 3. Now FOIL. Numerator, 1 times 1 is equals to 1. 1 times negative square root of 3 is equals to negative square root of 3. Negative square root of 3 times 1 is equals to negative square root of 3. Negative square root of 3 times negative square root of 3 is equals to positive 3. On the denominator, the two middle terms will cancel because these two are on conjugates of each other. We'll only need to multiply is the first two terms, 1 times 1, and the last two terms are positive square root of 3 times negative square root of 3 is negative 3. So, 1 negative square root of 3 minus negative square root of 3 plus 3 over 1 minus 3. In the numerator, 1 plus 3 is 4. Negative square root of 3 plus negative square root of 3 is equals to negative 2 square root of 2. In the denominator, 1 minus 3 is equals to negative 2. So, 4 negative 2 square root of 3 over negative 2. Let's write this as two separate fractions. 4 over negative 2 and negative 2 square root of 3 over negative 2. Negative 4 divided by negative 2 is equals to negative 2. Negative 2 square root of 3 divided by negative 2 is equals to the square root of 3. Negative 2 plus the square root of 3. So the final answer will be the square root of 3 minus 2. Tangent difference identity. Tangent A minus B equals tangent A minus tangent B over 1 plus tangent A tangent B. Now the example. Tangent pi over 12, same as the tangent sum identity example, we need to convert this first from radian to degrees. So pi over 12 times 180 over pi. Now that we got the degrees, we will now find two common angles that has the difference of 15 degrees. Tangent 15 degrees. Two angles that we can use are 45 degrees and 30 degrees. Tangent 45 degrees minus 30 degrees. A is going to be 45 degrees and B is going to be 30 degrees. So what's tangent 45 degrees? Using the 45 degrees and 45 degrees and 90 degrees special right triangle, we can identify that it's 1. So tangent 45 degrees is equal to 1. What about tangent 3? Well, using the 30 degrees and 60 degrees and 90 degrees, the special right triangle, we can identify that it's the square root of 3 over 3. So tangent 30 degrees is equal to the square root of 3 over 3. Substitute 1 minus the square root of 3 over 3 over 1 plus 1 times the square root of 3 over 3. So 1 times the square root of 3 over 3 is just the square root of 3 over 3. So 1 minus the square root of 3 over 3 over 1 plus the square root of 3 over 3. To simplify these complex fractions, what we need to do is to multiply the top and the bottom by the common denominator of those two numbers, which is just 3. So 1 minus the square root of 3 over 3 times 3 over 1 plus the square root of 3 over 3 times 3. So let's distribute. On the numerator, 3 times 1 is equals to 3 minus 3 times the square root of 3 over 3. The two 3's will be cancelled, so it is equals to the square root of 3. On the denominator, 3 times 1 is equals to 3 plus, and 3 times the square root of 3 over 3 is equals to the square root of 3. So 3 minus the square root of 3 over 3 plus the square root of 3. We could leave the answer like that. But let's see what happens if we simplify it further. Let's multiply the top and the bottom by the conjugate of the denominator. 3 minus the square root of 3 times 3 minus the square root of 3 over 3 plus the square root of 3 times 3 minus the square root of 3. Foil. 9 minus 3 the square root of 3 minus 3 square root of 3 plus 3. 9 minus 3 square root of 3 plus 3 square root of 3 minus 3. The numerator will be only half. 12 minus 6 square root of 3 because 9 plus 3 is 12. 3 square root of 3 and 3 square root of 3 is 6 square root of 3. The denominator will only have negative 6 because the two middle terms are conjugate of each other. So 12 minus 6 square root of 3 over 6. At this point, we can now separate this as two fractions. So 12 over 6 and negative 6 square root of 3 over 6. 12 divided by negative 6 is negative 2. Negative 6 square root of 3 divided by negative 6 is the square root of 3. We can also cancel directly the 2 6. The final answer will be 2 minus the square root of 3. Now that we're done with the sum and difference identities, let Ryan and Jesha discuss to you about the half angle and double angle identities.
Half angle and double angle identities. Trigonometric identities simplify the computation of trigonometric expressions. In this lesson, we will continue on establishing more trigonometric identities. Recall the sum identities of sine and cosine. Sine sum identity. Sine A plus B is equal to sine A cosine B plus cosine A sine B. Now, let's find the value of sine A plus A to get the double angle of sine. A plus A will become 2A. So, 2A is equal to sine A cosine A plus cosine A sine A. Adding sine A and sine A will become 2 sine A, while adding cosine A and cosine A will remain cosine A. So the equation will be sine 2A is equal to 2 sine A cosine A. Now that is the double angle identity of sine. This identity shows that twice the angle is equal to twice the product of the sine and cosine of the angle. Now let's proceed to cosine sum identity. Cosine A plus B is equal to cosine A cosine B plus sine A sine B. Now let's find the value of cosine A plus A to find the double angle identity of cosine. A plus A will become 2A, so cosine 2A is equal to cosine A minus sine A sine A. When two same circular functions are at the same side, they will be multiplied. Cosine 2A is equal to cosine squared A minus sine squared A. Now that is the double angle identity of cosine. This identity shows that the cosine of twice an angle is equal to the difference between the square root of the cosine and the square root of the sine of the angle. We can also make use of the Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. And the double angle identity of cosine to find other double angle identity of cosine. Cosine 2A equals cosine squared A minus sine squared A equals cosine squared A minus 1 minus cosine squared A is equal to 2 cosine squared A minus 1. And cosine 2A equals cosine squared A minus sine squared A equals 1 minus sine squared A minus sine squared A is equal to 1 minus 2 sine squared A. Other double angle identities of cosine are cosine 2A is equal to 2 cosine squared A minus 1 and 1 minus 2 sine squared A. Now let's proceed to tangent sum identity. Tangent A plus B is equal to tangent A plus tangent B over 1 minus tangent A tangent B. Now let's find the value of tangent A plus A to find the double angle identity of tangent. Tangent A plus A is equal to tangent A plus tangent A over 1 minus tangent A tangent A. At the top, tangent A plus tangent A is equal to 2 tangent A. On the bottom, tangent A times tangent A is equal to tangent squared A. So it will be tangent 2A is equal to 2 tangent A over 1 minus tangent squared A. Now that is the double identity of tangent. Now here are some useful identities. Cosine squared A is equal to 1 plus cosine 2A over 2 and sine squared A is equal to 1 minus cosine 2A over 2. Now let's bye.
Now let's move on the half angle identities of cosine and sine. Cosine squared A over 2 equals 1 plus cosine A over 2. To get the half angle identities of cosine, we will put a square root on both sides of this equation. It will become square root of cosine A over 2 equals square root of 1 plus cosine A over 2. Cancel the square root and square root on the right side. The half angle of cosine will be cosine A over 2
equals positive negative square root 1 plus cosine over 2. This identity shows that the cosine of half an angle can be expressed as the square root of 1 plus the cosine of the angle. Divide by 2. The sign positive and negative sign indicates that there are two possible values for the cosine depending on the quadrant in which the angle lies. Sine square root a over 2 equals 1 minus cosine a over 2. To get the half angle identities of sine, we will put a square root on both sides of this equation. It will become square root sine squared a over 2 equals square root of 1 minus cosine a over 2. Cancel the square root and square root on the right side. The half angle of sine will be sine a over 2 equals positive negative square root 1 minus cosine a over 2. This identity shows that the sine of half an angle can be expressed as the square root of 1 minus the cosine of the angle. Divide by 2. If negative sign indicates that there are two possible values for the sine depending on the quadrant in which the angle lies. Now, the half angle identities of cosine and sine are cosine a over 2 equals positive negative square root of 1 plus cosine a over 2. Sine a over 2 equals positive negative square root of 1 minus cosine a over 2. Tangent half angle identities. Tangent a over 2 equals 1 minus cosine a over sine a. Tangent a over 2 sine a over 1 plus cosine a. Tangent a over 2 equals sine a over 2 equals cosine a over 2.
Applying trigonometric identities to find other trigonometric values. Now that you already know the fundamental trigonometric identities, let's try to apply trigonometric identities to find other trigonometric values. So given one of the values of the function theta, find other circular or trigonometric functions of theta by using fundamental identities. So the different fundamental identities is what we're going to use to find the missing trigonometric values. And there is only one given, and the other values is what we need to find. These are things we need to remember. In quadrant 1, all circular functions are positive. In quadrant 2, only sine and cosecant are positive. In quadrant 3, only tangent and cotangent are positive. In quadrant 4, only cosine and secant are positive. We need to remember these things because it is needed to get or identify the missing trigonometric values when we only have one given of the values of the function. Example number 1. Cosecant theta is equal to 5 over 3. And theta is less than pi but greater than pi over 2. So we can find this equation in quadrant 2 because theta is greater than pi over 2 but less than pi, where pi is equal to 180 degrees and pi over 2 is 90 degrees. So by looking at the equation, we can identify its quadrant, which is quadrant 2. In quadrant 2, only sine and cosecant are positive,
Since the value of the cosecant is our only given, we need to find the other values of the trigonometric function of theta. Using the fundamental trigonometric identities, what value should we find first? Of course, the first value that we need to find is the one closest to cosecant theta, which is the sine theta. Since the reciprocal of our sine theta is the cosecant theta, we can really find the value of the sine theta. So sine theta is equal to 1 over cosecant theta. We need to substitute this cosecant by its given value. So sine theta is equal to 1 over 5 over 3. Since our denominator is a fraction, we need to get its reciprocal and proceed to multiplication. Sine theta is equal to 1 times 3 over 5. So 1 times 3 over 5, the answer is 3 over 5. So sine theta is equal to 3 over 5. So our sine theta is equal to 3 over 5. We already have 2 trigonometric values and we need to find 4 more trigonometric values. The question is, what is the next trigonometric values we need to find? Since we already have the sine theta and the cosecant theta, the next fundamental identities that we should use is the Pythagorean identities, which is square root of sine theta plus square root of cosine theta is equal to 1. So get the value of the cosine theta. So square root of sine theta plus square root of cosine theta is equal to 1. We need to substitute the sine theta by 3 over 5. Square root of 3 over 5 plus square root of cosine theta is equal to 1. Simplify the 3 over 5 squared. So 3 squared is equal to 9 and 5 squared is equal to 25. So 9 over 25 plus square root of cosine theta is equal to 1. Next, transpose the 9 over 25 to the right side. Square root of cosine theta is equal to 1 minus 9 over 25. Simplify 1 minus 9 over 25. So 25 times 1 is equal to 25 minus 9 equals to 16 over 25. So square root of cosine theta is equal to 16 over 25. Since we're only getting its cosine theta, we have a square root of cosine theta, we need to square both sides of the equation. So square root of cosine theta is equal to the square root of 16 over 25. Cancel the square root of the cosine theta. Then answer is cosine theta. So cosine theta is equal to negative square root of 16 over 25. So why negative? So we all know if our given is in quadrant 2, only sine and cosecant are positive. So therefore, our cosine is negative. Negative square root of 16 over 25. The square root of 16 is 4 and the square root of 25 is 5. So our equation will be cosine theta is equal to negative 4 over 25. So the next trigonometric values that we need to identify is the one closest to cosine theta, which is the secant theta. Secant theta is equal to 1 over cosine theta. We need to substitute the given value of the cosine theta. So secant theta is equal to 1 over negative 4 over 5. Since our denominator is a fraction, we need to get its reciprocal and proceed to multiplication. Secant theta is equal to 1 times negative 5 over 4. 5 over 4? The answer is negative 5 over 4. So secant theta is equal to negative 5 over 4. The next trigonometric values that we need to identify is the tangent. Then the fundamental trigonometric identities that we should use is the quotient identities. Tangent theta is equal to sine theta over cosine theta. We need to substitute sine and cosine by its given values. So tangent theta is equal to 3 over 4 over negative 4 over 5. Since our numerator and denominator are both fraction, we need to get its reciprocal and proceed to multiplication. So tangent theta is equal to 3 over 4 times negative 5 over 4. 3 over 5 times negative 5 over 4, we can cancel 5 and what's left is 3 over 4. And the answer is negative 3 over 4. So tangent theta is equal to negative 3 over 4. And lastly, the cotangent. Cotangent theta is equal to 1 over tangent theta. Substitute the tangent by its given value. Cotangent theta is equal to 1 over negative 3 over 4. Since our denominator is a fraction, we need to get its reciprocal and proceed to multiplication. Cotangent theta is equal to 1 times negative 4 over 3. So 1 times negative 4 over 3 is equal to negative 4 over 3. Cotangent theta is equal to negative 4 over 3.